All right, so we've learned about the sine law. Sine law was useful in finding angles or sides in oblique triangles. Same with the cosine law, but really sometimes you don't have enough information to use the sine law. Maybe then you can use the cosine law and vice versa. And so once we've done both of these, we'll look at which cases each law is best. And you'll kind of figure that out. Here, these are the versions of the cosine law. So this one really is the most popular version to show, most common. Really what happens is if we solve for cos C, that's what we get. Okay, so you don't have to know the development of the sine law or the cosine law, how it comes about. We did show you for the sine law. I'm going to show you for the cosine law. It's a little bit more complicated, but just so you know sort of where it comes from. So just like with the sine law, we cut this into two right triangles. So this right-hand one and the left-hand one. And this side is B. Lowercase b is opposite to capital B. I'm actually going to call this bit here x. That goes from that altitude to the end there. And then if that's x, then this would be b minus x. Okay. Now we're going to find relationships between the sides. I'm going to call this h for height. So if we take a look in this right triangle on the left, using the Pythagorean theorem, we get c squared equals b minus x all squared plus h squared. Okay. Notice how this is c squared equals everything in terms of lowercase a and b and uppercase c. So obviously we've got a b there, but we've got some other stuff. So I'm just going to expand this out, expand the bracket, b squared minus 2bx plus x squared plus h squared. Okay, so I've just expanded it, but I've got a relationship for c there. In my other right-hand triangle, I've got Pythagorean theorem says a squared equals x squared plus h squared. Well, take a look. Here is x squared plus h squared. So that means I can replace that with a squared. So now I'll have b squared minus 2bx plus a squared. So I've almost got it into a, b's, and c's, except I've got this x here. And I do have to include an angle. So it is called the cosine law. And so if I take a look at angle C here, cosine of angle C, so another equation, cosine of C will be adjacent, which is x, over hypotenuse. So now, if I solve for x, I'll get a cos C, and then I can substitute it in for x there. All right, I'm going to just rearrange in this step, put the a squared first, just alphabetical order, then the b squared, then 2b, and then instead of x, I've got a cos C. And voila, that is the cosine law. So I'm just going to rearrange it a little bit in that last term, a squared plus b squared, and then I really put alphabetical order in that term, so 2ab, and then cos of capital C. Okay, and then to get cos of C by itself, we would want to bring all the other terms over. Actually, what is easiest is because this term is negative, okay, then I'm going to bring this term to the left and the c squared to the right. So I'm going to have 2ab cos c equals a squared minus b squared. Oh, sorry, a squared plus b squared. And then I'm going to subtract the c squared because I'm taking it to the right. And then I want to divide by 2ab. And there you go. You can see the other version. Those divide out. So I get cos of c equals a squared plus b squared minus c squared over 2ab. So, do you have to memorize them? No, we'll give them to you, but it's a good idea to have maybe them memorized, at least have a good understanding. The biggest mistake students make, they get mixed up which side they put in. And so take a look, the terms that you're squaring and adding together. So a squared plus b squared, that's you're dividing by a and b, never by c. And these capital C and lowercase c are opposite each other. Okay, so always remember lowercase a and uppercase a are opposite, etc. Okay, so let's practice. It says find the missing side length. So I'm going to call this x. Okay, so x is the missing side. So if we're looking for a side, we're going to use this version of the cosine law. Okay, so the side that you're looking for, it's opposite the angle you're given. So side that you're looking for is opposite, and the other two sides surround that angle. So anytime you have, we call it side, angle, side, known angle, known side, then you can use the cosine law. So now I'm going to call it x, because that's what I've labeled. So x squared equals, doesn't matter which is a and which is b. So 13 squared plus 24 squared minus 2 times 13 times 24 cos of 45. Okay, it's a little bit messy. Okay, so you don't have to evaluate every term inside here. You do have a graphing calculator. I do want to see what you're putting into your cosine law. So I want to see this step. Get out your calculator, go to your mode key, make sure it's in degree mode, then go to your calculate screen and enter in the values. So 13 squared plus 24 squared minus 2 times 13. I use times, it's a little bit faster than the brackets. And then times cos of 45. Close the brackets, enter on that. Okay, you're not done, so 303.765. Okay, that's x squared. So now x is the root of that. But the good thing is you have it in your graphing calculator. I'm just doing the 3 decimal places sort of for safety. So now go second x squared, which is square root, and then you can do the second negative, which is the answer, and enter on that. And now you can, it doesn't say what to round to, normally nearest tenth, so 17.4. Okay, just one calculation, so I don't have to show more decimal places now because I know I don't have to calculate anything more. Okay, take a look at it, and 17.4 kind of makes sense. If you had left it as 303, totally doesn't make sense in that triangle, right? So just take a look for that. Okay, next one, you know all 3 sides, but no angles. So the only law you can use is, in this case, is cosine law. Even in this one here, you couldn't have used sine law, right? Because you need a one complete matchup, an angle and a side, and that's actually what we're looking for. Here is the side, and we don't know this angle, and we don't know this angle. Okay, so here I'm going to use the version where it's cosine of, in this case, x. Okay, now, really important, what's A, B, and C? So A and B surround that angle. So I'm going to call this A and this B, and then C is opposite the angle you're looking for. So this is going to be A 9.8 squared plus 6.2 squared minus 10.3 squared. Okay, all over 2 times A and B, so 9.8 times 6.2. Okay, so in your calculator, just be careful on this. Oops, sorry. So when we do this one, it depends. If you have a newer version of calculator, maybe it's better to do that fraction form. Okay, then there's no worries. Let me just move this up. So 9.8 squared plus 6.2 squared minus 10.3 squared. Then cursor down, 2 times 9.8 times 6.2, and that is your cosine value. So again, you're not done. That's not the angle. 0.234, just to have safety there, right? And then x equals, it'll be second cos, so cos inverse of that value. Okay, in your calculator, you go second cos of that answer. Try to use as many decimal places, so if you use the previous answer, you're good to go. So now 76, and again, we'll go to the nearest tenth, 76.5 degrees. Okay, now if you don't have the fraction capability, then you need to make sure you put brackets around the numerator. 9.8 squared plus 6.2 squared minus 10.3 squared. Close that bracket, divide, open bracket, 2 times 9.8 times 6.2, close the bracket, and enter. Okay, and you get the same thing. Just make sure you have brackets. So here, I'll go in red, make sure brackets around the numerator and the denominator if you're not using fraction capability in your calculator. Okay, so that's finding an side, finding an angle using the cosine law. Some properties to note. So x is 76.5. It's opposite the longest side, so that means it's the biggest angle. Okay, and sometimes you'll be asked for find the smallest angle, find the biggest angle, so that's a property that you have to be aware of. Okay, next one, solve the following triangles. Round all values to the nearest tenth. So by solve, it means find everything, all sides and all angles. So, okay, so in this case, we know two sides and the contained angle, so we can use the cosine law. I'm going to actually label these. So maybe I'll call this C, just because we have to solve it, so it's nicer to have some labeling there. So then I am looking for lowercase c. This would be B, this would be A. Okay, so now I'm looking for side C, so C squared equals, and then it doesn't matter which is A or which is B, because you're just, order doesn't matter when you're adding. Okay, so just sorry, I'm using my mouse, so I'm not terribly accurate. Okay, so I would put this all in your calculator. So clear, I'm going to have to move it down. So 17.3 squared plus 22. So 17.3 squared plus 22.4 squared minus 2 times 17.3 times 22.4 cosine 105. Okay, and again, really big number. Then you're going to need to square root that answer. Now, if you wanted to, you could go square root of all of that expression. That would just be one step. So 1001.645, so 1001.645, and then C is going to be the root of that, which is 31.6. Now, saying that, I was going to say 31.6, but we're solving, so we may need to use it in other calculations. So I'm going to go 31.649, 31.649. And so that's our side C. We now need to get the angles, right? I'm going to use the cosine law just because that is this is the topic for today, so I might as well get some practice on it. So for B, it'll be cos B equals, and so notice how in the formula that's given, it uses cos C. Well, now we're finding a different angle. Just means that you need to be aware of what the sides surrounding angle B are. So that's going to be 22.4. And the angle we just, the side we just calculated, 31.649. So I'm keeping 3 decimal places. It is in my calculator, so I'm going to use it. And then minus the side opposite, 17.3 squared. And then divide by 2 times 22.4 times 31.649. Okay, so in your calculator, we have, so 22.4 squared, and then we're going to add that previous answer, so second negative squared. Then we're going to subtract the 17.3 squared. Now, what I haven't done here is put it in a fraction, so I need brackets. So I need to close a bracket there, and I actually have to go back and open the bracket at the beginning. So I'm going to go second, delete, which is insert, open bracket. Okay, and then, so I should have opened it at the beginning. In any case, now I can go divide and then open bracket, 2 times 22.4 times that 31. So I'm going to go second negative again, that answer, close the bracket, and enter on that. It's going to be a decimal less than 1. Okay, so that's 0.849, so 0.849. Now to get B, we have to do second cos of that value. And again, you could do that all in one step. Sometimes you tend to make some errors when you do that. So now second cos of that answer, and I get 31.9 degrees. Okay, this was a distance, so it's just units because nothing was given. And so now I want to get angle A. I'm not going to use cosine law. I have two of the angles. So now angle A is 180 minus 105 minus 31.9. And remember, by using those unrounded values, so using what's in your calculator, you get the most accurate that you can. So now I can go 180 minus 105 minus that previous answer, and I've got 43.1. Oh, sorry. 43.1 degrees. Okay. So, oops, I'm going to, so this, either rewrite them all together. Oh, I should put here, this is B, this is A. Either rewrite them all together or highlight them or something to distinguish what you have calculated. Okay, so you're given three things, you have three things. There's six that you would have to get in a triangle. Okay, next one, solving this one. So this has three sides. So we want to calculate an angle. Okay, we'll need to get all three, but to start, calculate an angle. So taking a look at this, maybe I'll do this big one here. So if you want to call it C, you can. So here, that'll be cos of C equals, now the sides that form C are your A's and B's. Oh, that's not very straight, but you kind of get what I'm talking about there. I'm just going to erase that. Okay, so you're going to have 5.94 squared plus 3.81 squared minus the side opposite squared, and then divide by 2 times 5.94 times 3.81. Okay, and again, get out your calculator. I'm just going to clear off some stuff there. So 5.94, let me move it up a little bit, 4.94 squared plus 3.81 squared. Okay, now notice how again I forgot the bracket. So I'm going to go back before I forget. Come on. And then insert open bracket. And then I can finish it off. So minus, side opposite was 8.93. Okay, close the brackets, divide, open brackets, 2 times 5.94 times 3.81. Okay. Notice how it's negative, and that's okay. It's going to be negative if the angle is bigger than 90, and we'll talk more about that in a few lessons. But go second cos of that answer, and you get 131.421. So let's go back, negative 0.662. So then cos, we did inverse cos of negative 0.662. And then we got 131.421. 131.421. Okay. Which rounds to 131.4. Okay. So that's C. And notice how it's bigger than 90, so that makes sense. So now we've got that. Now to get the other angles, we can use sine law or cosine law. Last time I used cosine law. This time I think I'll use sine law. So I'm going to call this A and this B. Okay, so if I want to find sine A, I put it over the side opposite. Oops, and then if, oh dear. Then if I want to find, so then what do I know? I know sine of the angle opposite. So I want to match up, right? So that's now a match up. So 131.421, I'm going to put the 3 decimal places. And that's going to be over top of 8.93. So remember, if we're solving for sine A, we're going to have to multiply through by 3.81. And divide by 8.93. So in our calculator, over here, let's see. Okay, so I'm going to, again, in this case, we don't need brackets, so 3.81. You can put it in fraction form as well. Sine of 131.421. Close the brackets on that and then divide by 8.93. Okay, so that's your value of sine A. Now to get A, second sine of that answer. Okay, so 0.320 basically. And then A is inverse sine. But don't use the 3, try to use more decimal places. That's just sort of for recording. And then 18.659 degrees, which rounds to 18.7. Okay. And then, so now we've got those 2 angles, and now we want to find angle B. And so we can get angle B by subtracting from 180. Now, I'm going to subtract the 3 decimal places. The space there. And then, so when I do that, actually, if you have an older version, a newer version of the calculator, you can go up to, cursor up to, oops, there, 131, enter on that, then subtract the answer, or you can cursor up to it. Okay, and that's 29.9 of the rounding. So let's check it out. 29.9 plus 131.4. Okay, and then plus, we said, yeah, so 29.9 plus 131.4 plus 18.7 works out to 180, right? So you can always check, just you're rounding in that sense. Okay, so that's going to be that. That's angle B. That's angle A. And so I'm just going to, again, you can rewrite them because it's hard for me to write with my mouse. I'm just going to select them with red. Okay, so we've got the 3 angles. And we already have 3 sides. So we're done solving that question. Okay, now an application question. It says a pendulum that is 20 centimeters long swings back and forth. It travels 15 centimeters to the right and 15 to the left of its equilibrium position. Determine the angle. Okay, so here's sort of equilibrium. Here's the pendulum. Okay, and actually I can show you with this. So there's your pendulum. It's going to go back and forth, right? So that's what a pendulum does. You've probably used, if you've used a metronome in music or in science, they've shown you a pendulum, okay? So actually I'm going to extend it out to there so that it kind of forms a triangle, and then do another one to represent the other direction equally, and then join those up. That's pretty good. Okay, so the pendulum is 20 centimeters long. So this would be 20, this would be 20. And it travels 15 centimeters to the right and left of its equilibrium. Equilibrium's in the middle when it's hanging down, not moving. So this would be 15 here, and this would be 15, and this would be 90-degree triangles, right? So determine the angle through which the pendulum swings. So that basically this angle here. Well, what's nice about this is that it's these are 2 equal triangles, right? Congruent triangles. So you could use your regular trig. So you have a choice, really. You could use your primary trig ratios, but now that we've learned the cosine law, maybe we can use it, because take a look, we have those 2 sides are 20, and then this side here, then if we add it together, will be 30. So we could get that angle right away. So that's what we're going to do. I'm going to call it angle, this time I'm going to call it angle X. So just going to delete that. So here it's going to be cos of angle capital X equals, so now the adjacent sides, the sides that form that angle, are both 20. So 20 squared plus 20 squared minus 2 times 20 times 20 cos of okay, so 20 squared plus 20 squared minus the side opposite, which is 30 squared, all over 2 times 20 times 20. So calculator out. I'm going to clear off the last. So I'm going to use the fraction form this time because I do have that capability. Okay, and then I don't need brackets then. So 20 squared plus 20 squared minus 30 squared over then 22 times 20 times 20. Okay, it's kind of interesting when you use that fraction form, the answer you get will be in fraction form. So that's -1/8. If you had done it the other way, you would get a decimal form. It doesn't really matter. Then to get x by itself is cos inverse of -1/8, or it would be -1, this would be -0.125 if you did it decimal form. Okay, so then second cos of that answer, and enter on that, and you get 97.181, and it doesn't say what to round to. We'll go to 1 decimal place, so 97.2. Okay, and then write a sentence, okay, because it's an application question. All right. And then here, determine the perimeter and area of the following polygon. So take a look. It doesn't say that it's a regular polygon, but we're going to put that word in there. Otherwise, we wouldn't be able to figure it out. So a regular polygon means all the sides are the same length. Okay, so you're given here the distance from a vertex to the center. So just note that if you draw another like that, then you would have this side equaling this side, okay? And we want to find the perimeter, so we want to find the length of one of these sides, and then it's all going to be the same. So then this would equal this. I'm using 2 dashes because I've already used single dashes in the middle, and it's not going to be the same necessarily. Okay, so I'm going to redraw. Actually, I'll use my lines because I can't draw very straight right now. So I'm going to redraw that triangle. And this will be 6.5. And this will be 6.5. So it's isosceles. This is x. And we can find x if we know this angle. So one thing to realize is in a regular polygon like this, we could draw all the triangles. Okay, turns out that this is a 6-sided shape, so that's a hexagon. Okay, these aren't great, but close enough. So if it's regular, all of these angles in here are going to be equal, and there's going to be 6 of them. In a quadrilateral, or actually, I shouldn't say that, in the center like this, a complete rotation is 360 degrees. So that if we take 360 degrees and divide by 6, we get 60 degrees. Okay, so this is actually 60 degrees. Now, something interesting with this question is really you don't need trig. Now that we know that that's 60, if these two sides are the same, these two angles are the same. And they would have to add up to 120 because this is already 60. Well, half of 120 is 60. So these are all 60, which means all the sides are equal. So that means x is equal to 6.5. No cosine law needed. Okay, but if you didn't realize that, then you would use the cosine law. So x squared equals, and why don't we test it out? 6.5 squared plus 6.5 squared minus 2. Oh, sorry. Just a sec here. Minus 2 times 6.5 times 6.5, which is actually 6.5 squared as well, cos of 60 degrees. Okay, so if we get your calculator out for this, then we're going to have 6.5 squared plus 6.5 squared minus 2 times 6.5 times 6.5 times cos of 60. Okay, and then if we take the root of that, you get 6.5. Okay, so it does work. Okay, so this, I'm just going to put it here, x equals 6.5. You did all the work for that. Okay, so now the perimeter, if it is a hexagon, it's going to be 6 times 6.5. Okay, I already have 6.5 in my calculator, times 6 is going to be 39. And it's centimeters. Okay, now area. So that is a little bit, going to need a little bit of a calculation. One thing that we can do, all of these triangles are the same. So the area is 6 times the area of one of the triangles. Okay. Oops, that's not a bracket. So 6 times the area of one of the triangles. You could split it into 2 trapezoids. So you'd have the base of it and the other parallel base. You'd still need to find the height, and so really either one, we still have to do that. So, so this is going to be 6 times. The base of the triangle is 6.5, but we need the height, okay? And then we'll divide by 2. So let's calculate the height of the triangle. So maybe I'll do it in red. Actually, I'll do it. Oh, no, sorry. Do it in red here. Okay. All right. So that I'll call that H, and we know the angles are all 60. So I'm going to go sine of 60 degrees is H over 6.5. So H equals 0.5 sine of 60. Okay, so in your calculator, I'm going to go 6.5 sine of 60, and I get 5.629. Again, not done, so keeping some decimal places, so that's what I put in here, but we can use our calculator version. Okay, so now in my calculator, I'm going to go, I'll do the triangle first if you want. So 6.5 times that answer, so it includes all the decimal digits, divide by 2. Okay, so that's for one triangle, and then we have 6 of them. So 109.769. So, oops, 109.769. Okay, and then we'll round to the nearest whole number. It will anyway, so that'll end up being 110, and that's going to be centimeters squared. Okay. And that's it.